one, which is the continental drift theory. Continental drift theory. Now, on continental drift theory, uh, we have to understand what the theory states. So, the theory states that continents move or drift across the surface of the earth gradually. So, it says at first the earth was a one supercontinent known as Pangaea, and Pangaea means all lands. And this Pangaea was surrounded by a big ocean by the name Pathalassa. So Pathalassa means one ocean that surrounded Pangaea. Later, the Pangaea had split or divided into two large land masses, which were known as Laurasia and Gondwanaland. And Laurasia, this was a northern land. So Pangaea divided into two. The other part drifted to the north, the other part drifted to the south. And the part that drifted to the north uh, is that we call as Laurasia. So it included continents like Europe, Asia, Arctic, and North America. These were further drifted or disintegrated from Laurasia. But we also have Gondwanaland. This was the southern landmass after the split of Pangaea, which included the continents, for example, South America, Africa, India, Arabia, Australia, and Antarctica. So the Laurasia and Gondwanaland continued splitting and drifting apart. This is according to this theory of continental drift. So the theory of continental drift is about movement of continents. So since these continents that we have were at one place, congested, but it has disintegrated due to internal mechanisms of the earth, is talking about the movement of continents. So we have this geologist, the scientist who put so much effort in the theory of continental drift. This scientist was a German climatologist and a geophysicist by the name Alfred Wegener. Alfred Wegener. So, in his continental drift theory, the supposition is that at first the Earth was one. So this is Pangaea, as we see in the colored section. This one, the Earth was one. So the Earth was one, like here. This is Pangaea. It's about 225 million years ago. So later, Pangaea divided into two. So you see here. So there's Laurasia, Gondwanaland. So furthermore, in about the Jurassic period time, you see that this Gondwanaland here is splitting into South America, Africa, India, and other continents here. And this one uh, probably became Australia. And here, furthermore, you see the divisions here. So some of the evidence of continental drift theory would tell us that the continents fit into a jigsaw. So for example, if we take this South America and put it here, and we drag this one here, and we drag this and this here, you see that they'll fit into a jigsaw. So that is one of the, so this is probably the present day location of continents. So you see, this North America, South America, Antarctica, Australia, this is Madagascar, Asia, India, and Africa. These were one by the name Pangaea. So what are the evidence that support the theory of continental drift? So number one, it says the feet of the continents. So the present shape of continents suggests that their coastlines on the opposite sides can be joined. So some continents fit into a jigsaw. For example, let's come to here. So we see if we squeeze South America here, and Africa, Arabia, India, Antarctica, and Australia, you see that they are fitting into a jigsaw. Probably in my thinking, the gap here at the southern tip of South Africa, Cape Town here, probably this gap is due to denudation or depositional erosion, which has taken place for decades, million years of million years ago. So, but it sounds in the northern part, these continents do not fit into a jigsaw. And number three, rock type and structure similarities. So we said that rocks of West Africa and those of Brazil are similar. So if we come here, Africa and Brazil somewhere here, their rocks are similar. Because they show similarity, it means these two landmasses were at one place together. And then we have also fossil evidence. Fossil evidence. So fossils of plants and animals have been discovered in most parts of the continent, such as Africa, America, and Asia. So these fossils have been similar, meaning to say the land was at one point in time one, but after splitting, the species spread to other parts of the world. So we have also magnetism of the rocks. Say magnetism of ancient rocks, especially igneous rocks, shows that the continents were once a single entity. So what is happening? Rocks were magnetized in the direction of magnetic north when solidifying. So all ancient rocks on the continent show similar magnetic pattern, showing that all continents were joined together. However, this theory of continental drift has faced a lot of opposition, and therefore we look at what are the weaknesses of continental drift theory. So the weaknesses is that the theory fails to come up with a convincing mechanism to explain what could have been powerful enough so as to separate the Pangea. So where did the force come from which made Pangea to split? It's one of the weakness. We have also the evidence of similar in the coastlines has been challenged by water erosions. So because of water erosions, some continents cannot fit into a jigsaw. This has been taken as also a weakness. And also another thing is that the issue of fossils, the spread of fossils could have taken place because of movement of water. So from one place to another, and these ancient plants could grow in other continents. And since not all continents fit when joined, and some parts need to be removed for continents to join, this indicates also a weakness. So the theory focused very much on continental crust and did not state what happens to the oceanic crust. So this is the second part that we have covered, and thank you very much for your